I did log in. I'm just waiting for the screen to open. Ah, great. Beautiful. All right, so my name is Dan Leonardis. I'm going to talk about platform independent architecture. This time around, I'm going to be adding RX to the MVP talk that I had last time. So I'm going to start the same way I did last time, where I just want to remind everyone why platform independent architecture. Because, you know, most of the time as developers we think like this, where in reality we should be thinking like this. Why? Because most businesses today release an app with similar requirements. Not an iOS app, not an Android app, just an app. So I'm going to talk about a little recapping the building blocks that I talked about last time, and then I'm going to do a deep dive. You want details, I'm going to give them to you. I'm then going to talk about the platform dependence. We could really do this reactively, and then I'm going to talk a little bit about the future to see if we can do better. So it all starts with what? You have to know what you're building before you ever pick an architecture. Otherwise, you're just wasting time. Otherwise, WTF. And you know, do me a favor, don't just start coding. You know, architect first. Think first. Think, how do I put these major pieces together? Think, what patterns of clean code make the best sense to use? What are the system pieces do I require? Do I need a database? Do I need some kind of caching, et cetera, et cetera? So I talked about getting clean with clean code. And for those that don't know, clean code architecture aims at making as much of the business logic testable while looking at everything else as a plugin. This architecture works by implying the dependency rule, which states that the source code dependency can only point inward. Nothing in an inner circle can know anything else about the outer circle. Enforcing this rule means that crossing boundaries should be done by passing simple data structures between the two using interface relationships, such that the source code dependencies oppose the flow of control. I talked about Android MVP and iOS VIPRE really were the same thing. They're separating out those use cases. The concept separates the presentation layer from the logic so that everything about how the interface works is separated from how it's represented on the screen. I showed this detailed diagram. The entities are your models, the view model and the response model, just your plain interfaces. And everything on the left side of the dashed line is platform specific, where everything on the right side was independent. And then said some people, they wanted to know more. They wanted to know, how do you do calls to the network? How do you do databases? Well, here you go. Here's the data ingestion part, where above the dashed line is your platform, your business logic, and below is your platform-specific material. And here's basically the whole thing. So everything on the bottom right is platform-specific. Everything in the top left is basically your business rules, your use cases, your platform-independent type of architecture. I went into an example. The NHL application released in February 2016 used a platform-independent type of architecture. We had this unruly onboarding requirements where, if you can see it, the left is purple and you were Canadian and the right you were US. I was sorry if you're Canadian. There were permutations of push notifications, favorite teams, paywalls to get money out of your pocket, logins, etc. Well, we thought first. And what we came up with was a state machine. We said the state machine pattern is platform independent. We have the solution. And each piece at the bottom right, each piece, each permutation was definitely testable. And we launched something that looks like this. So the video captured basically everything I just showed in the last screen. You got your splash screen, you have the pick your favorite team, then you had your, pay for this app so we can make some money, and then there was the whole concept of you got push notifications, and then you eventually landed on some kind of homepage. And that's what we delivered with independent platform architecture. All right, so look, we didn't do it once, we did it twice. But this time for Arena, a ballpark replacement app for games and events, we included the application start. In other words, when you go into the background, when you're in the foreground, and we introduced the state pattern as well. Android's on the left, iOS is on the right, but we did something different this time. This time we introduced Rx into our designs. So how'd we do it? how do we take clean code MVP and add RX? I'm going to show you, but we have to go deeper into code here. Now, look, Reactive Rx, it's a tough subject on its own. I'm not going to explain the benefits of using it or how to use it. What I'm going to focus on is how it fits into an MVP app in order to complete the platform-independent architecture. Now, look, I can't go show you proprietary code that I don't own. So I came up with an example to demonstrate MVP in an Android app. I'm going to walk with you every step of the way on how we could take this simple app that wasn't using MVP and change it to, that wasn't using RX to have it use RX. So what was this little sample? What was it supposed to do? So all it's doing is loading a list of now playing movies where I had requirements to show a poster, a title, release date, and ratings. I wrote things like a product owner. As a user, any rating of 8 or above should be starred. As a user, I don't want to see ratings rounded to the nearest digit. Things like, as a user, while you scroll, keep loading another set of data. So given that, I wrote this little app. So once again, here's an image of the MVP architecture used. Notice the red box. So this is where I have a static thread basically doing all the work. I created it by hand. It's spawned by the presenter, or it's called by the presenter and spawned in the Interactor. It calls the Service API, which is using Retrofit. It translates the external RESTful API into an internal representation, and then it returns the data on the main UI to any kind of callback. When no callbacks, it caches the data in memory, and it's a static reference in order to live past the lifecycle recreation, which destroys the view control of the presenter and the Interactor in an MVP type of style. Now, I'm magically going to hold this and switch to code, but let's see if I can do it. Well, hold on. I gotta put this down. Oh, still the wrong one. Hold on. This is it. I apologize. All right, so this is the MVP app with no RX in it. Basically, what you see is I have a static thread up here. If you're not sure why I'm using static, basically it allows me to cheat and not worry about the Android lifecycle. So this thread can complete, and then people could hook up via callbacks and unregister callbacks when the system dies and or use a weak reference. So why use the thread here? The thread is started when basically you're like, hey, load more information. Thread start. If not, we hook for a callback. The real meat of what I'm trying to show you is what is this thread doing. So at the bottom of this class, and this is all online on GitHub, you will receive links to this. So I'm going a little fast. I'm just trying to get a point across about putting RX into this code. So what does this thread do? It calls our service gateway, all right, gets some kind of data back, and then it processes the results. It caches them into some kind of runnable. If there are observers, callbacks hooked up, I run the runnable cache on the main UI thread, which is this handle that's passed in, and that's how I'm able to do it all by hand, no RX. Now let me show you the service gateway in this app. All right, so what is this doing using Retrofit? So it's getting a service response call from Retrofit. It then has to look at, is it successful or not? If it is successful, I'm calling this translation where, as you guys know, we're crossing that boundary. I have to change a external RESTful API into some kind of internal format, and that's being done here. So all done by hand, no RX. Okay. All right, here we are going to talk about adding reactive. So step one, we want to use RX2 with Retrofit. Let's simplify the gateway, and you can see this shown in the image in red on the screen. And then step two, let's remove the thread that I wrote, the callback and caching, and we're only going to use RX the entire way. So the Interactor is going to be mucked with twice, the gateway is going to be the first step, and the presenter will be part of the second step. All right, now I got to go back to the screen. Okay, so here's that Interactor again, where we had the run method. And you noticed last time it was processing results coming back. Now I'm just adding RX at this point. So all I'm doing is I'm subscribing to my data, and I'm saying if it's successful, create my runnable cache. If it's not, create a runnable cache with some kind of error code. And then in the gateway itself, the gateway itself simplifies, where all I'm basically doing is taking the observable that comes back from Retrofit, I'm subscribing to it on a I/O thread, I'm doing my computation, in other words, my translation from external to internal data on the computation thread, and I like to do this in all my RX code because I like to know where I fail, if I fail, and then the translation is pretty simple. It looks identical, except it's just wrapped with the observable. Step one's pretty simple. Let's go to step two. Look how much less code I have in this Interactor now. So the thread's gone. What was basically replaced is now I'm taking this observable callback from the service gateway and I'm going to throw it to the presenter. The presenter is now going to do the bulk of the work. Why? Because you don't need to do all this type of hand-holding in the Interactor anymore. So this got simplified a lot. The only thing I have in the Interactor was I wanted to delay the screen so you can see a little spinner in that GIF that I started with at the beginning. So it's the only real thing it's doing. So let's go to the presenter, see what the presenter's doing. All right, let's start at the top. What you see here is I basically have a static, again, to last pass lifecycle creation. I have this request cache. What RX allows me to do is basically I can cache my observable so that during rotation, I could hook back to it later on. So now I don't need to worry about having runnables being saved into a static thread. No, let RX do the work for me. So let's see where I use it. There we go. So when I want to load more information, the presenter's going to say, look, if I don't have a cache already running, I'm going to create a new one. So it goes to the Interactor, calls load more information, which you know is going to the gateway, doing all that data ingestion. Now here's where it's doing a translation for the presenter. What I was doing on the original example without RX, the translation, in order not to have another thread, was being done on the main UI. If you want your UI to be snappy, why not just continue to do it on a background thread? What RX allows me to do is bounce from scheduler to scheduler, pretty straightforward. So now I said, look, I have this data coming in that I want to process for the presenter. I want it specifically to be mutated for the UI, and here I'm doing it with this translation for presenter function, which I'm saying, look, I want to be able to do this on the computation thread. Schedule, I should say. So here's this translation. All it's doing is taking data in, like this movie list info, and it's translating to a list of movie list info that's specifically ready for review. That's all it's doing. Now let's take a look at the subscribe. Oh, and here's the cache piece. So basically I'm taking that retrofit observable, and I keep throwing it up, keep throwing it up, keep throwing it up, and everybody's like doing something to it. So originally it came up with raw data from a RESTful API, and then it gets mutated to be internal. Then it comes to the presenter. The presenter goes, I want to add my own mutation to it. I want it to be ready for some kind of UI, and it keeps going up the food chain, and I cache it. I cache it specifically because to subscribe, you'll see that to subscribe, I got to have a disposable. I have to be able to unhook from my observer so I don't leak my activity or presenter or anything else that was created during an activity lifecycle. So I have my disposable, and I request my cache. I'm observing up on the main UI thread because I have to mutate the views. And what I have here is on complete, I show some kind of data, and on fail, on complete, I basically relinquish the cache, and on subscribe, whether it's good or bad, I update the UI in either case. And then there's an on destroy in here somewhere, which basically goes to the disposable list and says remove all disposables when you have a rotation. So that's in 2 steps how I was able to add Rx into an MVP type of application. All right, testing. So since we started with an MVP example without reactive, it pays to say that everything I did in that first sample project was unit tested and espresso testing. When I forked and migrated to Rx, every step of the way, I made sure to update my unit test and espresso test. Can you tell which espresso test just run above that were Rx and which one wasn't? I bet you can. So in other words, I had a UI and I changed the underlying code. I had a car, I basically redid the engine, and the car still looks the same, still acts the same. All right, now let's go and talk about this for platform independence. I was looking to do a Swift example for you guys and show you that, but I didn't get a chance to do that. So instead, I have the next best thing. I'm showing how Reactive was used in a production app. So a little self-plug here. I created this app with a few contractors, which is just a sample game of allowing you to play charades on your phone. You pick a phrase, you take a picture, you hand it to your friend, and they try to guess the image. It just got released on the App Store and Google Play, so check it out. I'm going to use this to demonstrate how I used MVP, the same architecture on both platforms, doing it reactively. First, though, I want to brief talk about different streaming caps. You have Rx Android, Rx Java, Rx Swift. They're almost identical APIs, so usage of these tools throughout MVP architecture is pretty similar, so I strongly urge these for platform independence. Reactive Cocoa, Reactive Duct2C, Reactive Swift, they're still streaming technologies, but they favor iOS. I'm not going to talk about which one's better. For me, when I was using Objective-C in my production app that took god-awful long to make, I was stuck using Reactive Objective-C. The syntax is a little different, but the concepts are the same. Observers, subscribers, rack signals. Look, it's different names, but it's still doing the same thing. I'm interacting with streams. So let's go deeper. So here's a really simple screen in the app. It loads a list of phrases for you to choose from. It does a network call to fetch the data, then displays the data in a simple list. As a reminder, here's the same architecture I used on both platforms. Oh, good, you don't have to squint too much. So with the setup, in the presenter, we created the gateways. This is Android code now. If you don't know that, then all right, that's a bigger problem. So the presenter uses the gateway to fetch the data and caches it. The gateway calls the retrofit service. The network calls on the IO thread. It translates the results onto the computation thread. And for the translation, I'm taking that web response and I'm translating it into something that the internal business logic understands, a simple pick phrase object. Updating the UI. In the presenter, I'm subscribing to the cache. We observe the subscription on the main thread so we can update the UI when we handle errors and success. And when there's an error, I'm just launching the same path again. So I show the user, oh, something failed, they hit OK, boom, back into the same path. Now, to talk about iOS. Syntax is obviously different, but look how similar the flow is. In the presenter, we create the gateway. The presenter uses the gateway to fetch the data. There's no caching, since in iOS, the view controller just doesn't magically disappear. The gateway calls the AF Network Service API. The network calls on the IOED thread, and it translates on the computation thread. For the translate, I take that web response and I translate into something the internal business logic understands, a pick phrase object. Updating the UI. In the presenter, we subscribe to the rack signal, which is this observable, and we observe the subscription on the main thread so we can just update the UI. We handle errors and success. Errors, just launch the same path again. Squint even harder. Just kidding. All I meant to show here was there was no retrofit API for Objective-C, but I made my own. And this was the only class I needed to write to do the same thing. And that's how simple it was to wrap a regular, post, get, network library with reactive for Objective-C. Pretty neat. All right, look, we've talked about some simple MVP examples where data was translated from external formats to internal formats, then from internal formats to UI formats. Let's get into something a little more juicy. Let's go deeper. Logging. Seems simple, till it's not. When we added Firebase for push notifications, we noticed that upon logout, we needed to remove the user's device ID from our server. We needed to remove their specific device ID so we didn't publish to it when another user logged into the device. So you can't log in until the last person successfully logged out. Therefore, logout was written so it did a retry with backoffs. So it takes a while for bad network connectivity. If it fails, after a retry backoff, we just remove the token on the next launch. So what you saw on the screen, and I'll just replay it again real quick, especially for iOS, is when you log out and you have no network connectivity, and then you try to automatically log back in, you're just given this wait signal. If I put, this is on my device, if I put the airplane mode off, the logout's able to complete, and then allows you to go through the login mode again. Let's talk about it, let's show it. So in Facebook's SDK, the login and logout are not reactive. So to merge an already existing code, we introduced a subject. A behavior subject just emits the last received data, then acts like a normal observer. So for the login, the subject holds our last given state. Login's idle, login error, logging in, logging out. We process this state from the subject. We take while in some conditions, we skip others, and then we subscribe. For logging out, in order to log out, we have to remove our token and call Facebook's logout at the same time. We do that asynchronously, but we have to process the results synchronously. How do you accomplish this? Just zip it up. iOS. Facebook's SDK login and logout on iOS are not reactive. So to merge this already existing code, we introduced the subject. Behavior subject just emits the last received data, then acts like a normal receiver. I had to set this up a little more on Reactive Objective-C by using a replay last, but it acts the same way. Login. The subject holds our state. Login is idle, login is an error, logging in, logging out. We process this state from the subject, take while some conditions, skip other, then subscribe. Man, this looks mighty similar. For logging out, in order to log out, I had to remove the token from our server and call Facebook's logout logic. We do that asynchronously, but need to process results synchronously. How do you accomplish this? Just zip it up. So where do we go from here? We know we're going to use Rx as much as possible. We're going to make our code reactive. But can we do better? And can I set myself up for the next talk? The answer is yes. And a lot of it comes down to those two diagrams on the screen, which I did borrow from Jake Wharton's talk on managing state with Rx. What we can see here is that we have a lot of intrinsic code in the center to hook all this up. We have a bunch of UI callbacks that are not Rx-based, and we have to hook them in manually. So that presenter gets mighty big on a lot of our programs in MVP. But we could do better by removing this intrinsic boilerplate code and have the asynchronous events handle changes directly. So until next time. Look, it's a long talk. There's a lot of information. If there's anything to take away from this presentation, I urge you to understand in terms of polar thinking when it comes to clean code architecture. Polar thinking is simply wherein as you see the going togetherness of things that you thought to be mutually exclusive opposites. In other words, you wouldn't know you were right unless somebody else was wrong. Normally, when we think right and wrong are mutually exclusive, But when you're capable of polar thinking, you see that they go together. A person who feels in a polar way, who thinks in a polar way, see figure and background going together. He doesn't see them as being mutually exclusive. In the image that I have here, it's not funny unless the father and the child go together during a live broadcast. So I challenge you to think one app. I challenge you to think platform independence. That's it. Questions? Okay, I got a question. Oh, there's a question. Go ahead.
So, in your example, you just had like some failure messages, like looked like you were just logging errors when you like when your gateway service failed.
Okay.
So like, what do you actually do in a production app?
Sure. So the question was, what I do in a production app on an error, one of the screens in the gateway showed that I logged the error. Actually, what I'm doing is it's propagating up. So because there's no one subscribed to that specific action, I'm just, think of it as decorating. So as it goes up the stream, I'm decorating. There was an error here. So when you have to debug RX, as most of you know, it becomes a pain in the neck to figure out, hey, in production I had some kind of crash. Where did it happen? Well, if you start logging these errors as you pass them up, then you're able to determine, okay, it failed at the gateway itself, I got bad data in. Or it failed in the middle, it translated wrong. Why? My translation wasn't written correctly. So what I did in that case was I passed it up the wire. And what I did in a production app, which was on one of the slides, I will go to you. This one. So you would see where it says like show error. Like really what that code had in the production app was it said to the user, there was a kind of, generic error, please try again, and they hit okay. But what do I see as the developer? I see this trace of logs that, oh, it failed in the gateway. My, guy that wrote the service gave me crap and it failed somewhere. But to the user, it's like, go try again. And sometimes it is a valid error. There wasn't no connectivity, it timed out. They try again at that case. Now you can do anything you want at that UI level, but here is where I handled it, right? At this subscription inside the presenter that's going to say, hey, I'm updating the UI somewhere. Very good question. Any other questions? I got a question for you guys. How many people, raise your hands, uses Retrofit 2 and RX2 in their code right now for production? All right, there should be more of you. But that's a good sign, because that means I got more talking to do. Thank you very much, everybody. Thank you for your time. And all the code will be online for you to look at. Not trying to hide anything.